recording again. Okay, so back. This, let me check. Is it now doing the recording? Yes. Okay. Yeah. So what is power electronics? Power electronics may be new to you, okay? But actually we use it quite often. You will know the reason later, okay? And here, as stated, it is a special branch of electronics. So you guys should learn electronics in level 2, right? So in year 2. So actually, you can use the knowledge or the tools that you learned from the electronics and then apply those knowledges into this subject. It is because in this subject we use quite often the circuit analysis. For example, KCL, KVL, and then for AC stuff, yeah, one of your classmates asked me what is the most difficult part in this subject. I would say that it may be the AC to DC conversion, thyristor, yeah, or thyristor converter. It is because in that part, integration will be required to solve the circuit problem. Yeah. Um, so for the problem, we found that just like a circuit actually, okay, and then you need to look at the circuit carefully, and then do analysis or even derive some equations for calculations or reforms. Okay, so that's the brief idea for this subject. Okay, so it is a special branch of electronics. So why is that special? So it is because power electronics. Why there is a term power? It is because mostly we use that for power distribution and transmission. Yeah, so the power level should be much higher than what we use in our mobile phones. Okay, of course, power electronics can also be divided into in terms of power levels. It can be high or low. Okay, yeah. So and it is the technique, okay, to do control or conversion of the electrical power using semiconductor. Okay, so all the components are made of semiconductor materials. Okay, okay, and yeah, this is the brief idea. I can give you the brief idea of the power electronics interface. Okay, so the input can be AC, DC, or any signal. Okay, and then there will be a power electronics converters, for example, DC-DC converter, AC to DC converter, etc. Okay, and then we will have our desired output AC or DC with the designated magnitudes. Okay, yeah, and then in practical there should be also the sensor to sense the output if that is what we want, and then there will be a feedback, and then to tell the controller to feedback the signal again to adjust the output. Okay, so this is the quite common or generic idea of power electronics interface. Okay, so here I give you some examples of power electronics applications. So we usually use power electronics to harness renewable energy. So actually we can say that if you want to use the renewable energy or collect the renewable energy, we must use the power electronics interface. Why? So for example, to collect the solar energy, we need the solar panel, right? So for the solar panel, the output should be DC, So if we want to use that DC power for our AC load at home, so we need the DC to AC converter, right? So this kind of converter is one of the power electronics stuff, okay? And then the other thing is the storage of electricity. So similarly, okay, so for the batteries, um, as we have now, so all the batteries are DC, okay, all the batteries are DC. So if your source is AC and then want to store those AC power to the batteries, you need to do the AC to DC conversion. Okay. And then, of course, the purpose is to increase the efficiency of transmitting electricity. So later you may know why, or can get some ideas. Okay, and then as well as the efficiency in consuming the electricity in motor-driven systems. So motor drives is also one of the topics in our subject, and Dr. Yang will deliver this topic. Okay. And then for the power electronics applications, it can be mostly divided into 5 sectors. So actually, you can see that the sectors are quite broad, right? So it can be up to aerospace applications, or even for use, residential use. Okay, so actually I mentioned, right? So power electronics may be new for us, but actually we use it almost every day. Okay, and later I will show you more examples. And yes, I also mentioned this one, right? So the power electronics applications can be classified into 2 types in terms of power level. So for the low level one, so the applications can be mobile phones, motor drives, induction heating, right? So I cannot say all, right? But yeah, some of you should have one of this kind of appliance at home, right? And then welding, heating, and lighting. So those belong to low power power electronics applications. And regarding to the high power application, so it's also very easy for us to imagine, right? So power transmission and distribution should belong to the high power level applications. So here HVDC, and then UPS, power supplies, etc. Okay. Yeah, so again, if you have any questions, please feel free to leave me the message and stop me. Okay. Okay, so this is the first application examples of using power electronics interface, uh, powering the information technology. So this example is PC, computer. Okay, so in a computer, we know that there are many components, and those components may not have a standard input voltage, right? So for example, from this schematic diagram, so one component may require 5 volt, while the other one require 0.5 volt. But your source is from utility, right? So that should be the AC, although the frequency is very low, 50 to 60 hertz. And then, yeah, but no matter how, it is a AC source. And then if, yeah, in a computer, I don't know if you DIY the computer before. So there should be a transformer or power supplies. Okay, so that should be the DC one with the 24 volt. So here we need to do the AC to DC conversion, right? AC to DC conversion. Yeah. So and then this transformer can only um, deliver 24 volt, right? But other components, as mentioned before, they need different voltage levels. So here we need to do the DC-DC conversion, right, to step down the voltage. So from 24 volt to 5 volt, or 24 volt to 0.5 volt, and so on. Okay, so this is the example why PC also needs the power electronic interface. Okay. And the other example, cell phones, right? Cell phones. So for in the cell phone, there should be a battery cell, right? So for the time being, the output voltage level should be 1.5 volt if we use the battery. Okay. So but inside the cell phone, they also still have different components requiring different levels of voltage. So this is one of the example. If we have a component requiring 9 volt, so we need to do the step up DC-DC conversion, but at the same time we step up the voltage. And then the other applications are robotics and flexible automation. So actually, for using the power electronics, we can enhance the flexibility of control, right? This is because you may already have some ideas, right? We can transform or convert AC to DC, or if that is the DC-DC conversion, we can also change or adjust the magnitude. So it means that we can control the speed, right? The speed can be adjustable, right? So for motors. So this is one of the very common applications for using power electronics interface. Okay? And this picture shows you the brief idea. So again, the source is usually AC, right, from utility, and then to the PPU, and to drive the motor. So the motor, of course, can be AC motor or DC motor, but no matter how, we still need to do some conversion. Okay, and then we usually have the sensors, and then feedback the signal to the controller, and then do adjustment again. So this kind of closed loop. Okay, and then the motor, of course, to drive the load. Okay, so here we can use the power electronics interface. So do the AC to DC conversion. Okay, or even so from the EV, so some of you may know that, right? So the energy can be generated from braking, right? So kind of that. So it means that the power can be bidirectional, right? So this is also the beauty of using power electronics interface. Okay, and then the other application, induction heating. So I guess some of you may have one at home. Okay, so inside the induction heating cooking machine, there should also be a power electronics interface to convert the AC source to AC again. Okay, but the frequency is different. Okay, so for example here, for induction cooking, the frequency can be up to 24 kilohertz, and for induction welding, the frequency can go up to even 2 megahertz. Okay, so when compared to the frequency of the utility, 50 or 60 hertz, it is much higher, right? So we need the power electronics interface to do adjustment or conversion to fit our use. Okay. So this one very similarly, okay, but the other way around. Okay, so this one is the electric welding. So electric welding needs the DC power. Okay, DC power. So before that, induction heating, we need AC power, high frequency AC. Okay, induction. So once we have the term induction, so we know that that should be related to AC. Okay, and here electric welding should be related to DC. And so we here also need the power electronics interface to convert the utility AC DC for welding machine. Okay, and so any question for the previous subtopic? Very easy, straightforward. I guess no question. Okay, so this is the other subtopic, so energy and the environment. So actually this slide just summarize why we want to use the power electronics. The first reason should be money, right? Can save our money, save our cost. Okay? And then the other reason to protect the environment. Okay? Okay, so one of the systems, or one of the first systems that the scientists or the engineers want to change, okay, from the conventional approach to power the electronics or electric driven approach. So that is the motor. It is because this is not the very updated figures, but we still have some ideas. So the portion of motors is the largest. Okay, so almost over 50%. Okay, so it means that if we can change this part, we may be able to save energy or even the cost. Okay, so for using the power electronics, we can adjust the speed. We know that, right? And then we can also replace the hydraulic, the conventional approach. Okay, so it may be lighter and maybe cheaper, and the energy conversion efficiency can be higher. Okay, and the other session is lighting. Of course, this is the high frequency. So actually, we can see that there is a trend for lighting. Okay, so initially we have the blob, and then CFL, and then LED. So besides the technique, actually inside those technologies, we can see that the frequencies for lighting is increasing. Okay, so the operating frequency for lighting is increasing along this trend. Okay, and here also have the other link for your information. So actually, this link just want to tell you why LED is preferred now. It is the main reason should be again to save the cost, save your money, and then the lifespan can be long. So here is a comparison among those three lighting technologies. Okay. So here we can see that so LED needs small energy, right? But can give similar lighting level, okay? And the lifespan is much longer when compared to the previous two technologies, okay? Although the starting cost is relatively expensive when compared to the other two, uh, the average cost during the life of the LED should be much lower. Okay, so that's why LED is preferred to save energy and cost. Okay, so as I mentioned, CFL LED needs high frequency. Okay, so that's why we also need the power electronics interface to convert the low frequency AC to high frequency AC for CFL or LED use. Okay, so the other big sector should be transportation. So transportation, I think EV is not strange for us, right? It is because in Hong Kong, we can see quite a number of Teslas running on the road, right? Yeah. So actually, this is also a trend, but it should depend on the support of the government. Yeah, it is because um, conventionally, we can just get the gas, right, from the gas station if we have the conventional automobiles. But if we have the EVs, we need the charging station. So we need the support of the government, okay, to build more station or to reduce the test or yeah, etc. and so on. Yeah, yeah. And besides the vehicles, actually the other countries also try to apply the techniques to rail, light rail. This is the light rail driven by electricity, and even they're trying to develop electric-driven airplane and also the boat or even ships. Okay? So that's the trend because the power electronics can, or electric driven system can save cost, they believe. Okay. And the other sector should be the renewable energy. Renewable energy. So I mentioned before, right? So if we want to use the renewable energy, we must use the power electronics interface. So solar energy collection is one of the very common examples. So here we have the term PV, right? Photovoltaic. So this is actually the conversion term. So from light to voltage. Okay, so or other term, we sometimes we call it a solar energy system. So anyhow, we use this kind of device to collect the sunlight with specific wavelengths, and then to generate electricity. Okay, so so the output here is DC, Okay, and so but for our load at home, mostly AC, right? So DC to AC, we need an inverter. Okay, and then DC, we can store those DC power to the batteries, which is because batteries are also DC stuff. But we need to regulate the voltage and then store into the battery. So with that process, we also need the power electronics interface. Okay, or if we want to sell the power collected from the solar panel to the utility, we also need to use the power electronics interface to how to say, to standardize the quality of the power. Okay, yeah. So how to improve the power quality is also one of the purposes, okay, for using the power electronics interface. Okay. And the other application is the wind electric systems. So similarly, say if we have the wind turbine to collect the energy, the output should be no matter how the output. So actually, the wind speed we know that it should be unstable, right? Sometimes the speed can be high, sometimes low. So we need the power electronics interface to regulate the voltage, okay, and then to store or even for use, okay. So in foreign countries, we can see that sometimes we can see that there are some solar panels installed on the roof, or even recently we can see those hybrid systems. Okay, so they combine the solar panels, the PV panel, with the windmill. This is the vertical windmill, right? Or this is also the other product with the similar purpose. So on top of that, those are the PV panels, and then actually it is also a small windmill. Okay, so it can be used, or the energy can be collected during the daytime or nighttime. Okay. And then the other sector is the utility applications. So this is the UPS actually. So these applications will be delivered in more details by Dr. Yang in the second half of this semester. Okay, one of the topics is called applications. Okay, yeah. So here I just briefly introduce. Okay, so this is the UPS. I think some of our PCs also have the UPS. Okay, so UPS now is not a big deal. Okay, so even at home we can use we can have one. So here give you an idea how UPS work. Okay, so in normal situation, so there is an input and the output. So so in normal situations, some of the energy from the source will be installed into the battery. Okay, and there is also an inverter standby. Okay, and then during the power outage, so the AC input cannot deliver the power to the output. So during that time, so UPS will function. So the battery stored, the power stored in the battery will be delivered for the loading. But it is because again the output of the battery is DC, right? So we need a inverter to convert the DC to AC to the loading. Okay, so that's a brief idea for how the UPS works. And again, aerospace applications. Actually, I mentioned one term, right? Hydraulic before. So actually, for using the electric-driven system, the hydraulic or the conversion approach can be replaced. Okay, so for using this kind of system, what can we get in terms of advantages? So the cost can be lower, the weight can be lower, efficiency, reliability can be higher. Yeah, it is because so in this system it can be relatively simple, right? So for example, we can use the switch to replace the valve, okay, and even the motor, the electric motor itself should be much lighter than the hydraulic motor. Okay, so yeah, so that's why now we prefer using electric-driven system. Okay, so yeah, so keep going. Now it's 9, 10, 10, 15. We still have time. Okay. So yeah. So any question up to now? Up to now? No. Okay. So let's start the other topic: efficiency and power density. Okay. So yeah. Up to now, we know that, or we have some ideas why we want to use power electronics. Or actually, for the time being, we have no much choice. So if we want to do efficient energy conversion, power electronics interface may be a good among choices. Okay, so for the power electronic systems, it can give us these things. Okay, so in terms of power density, size, weight, cost, EMI. Yeah, so these are the main advantages that we can get for using the power electronics systems. Okay. Okay, so we talk quite a lot on efficiency, right? So okay, for using the power electronic systems, we can enhance the efficiency. But how is the correlation, right, between the output and the efficiency? Okay, so here we'll give you some idea how the efficiency is very important for power electronics system. So this is a very, very simple diagram, right? So here is the power electronics equipment. So of course we have the input and then output. Yes, I heard what is it? Let's see, I heard some sound. What is that? Okay, right, we keep going. Okay, so we have the input and also we have the output. Okay, and for all devices in practical, there should be some power loss, right? Okay, so the relationship here is very simple, right? So input power should be equal to output power plus power loss, right? Okay, so we can actually use these three terms to determine our efficiency. So this is efficiency, the symbol is eta. So eta is equal to P naught over P in actually, but P in can be expanded as the summation of the P naught and P naughts. Okay, and then we arrange the terms so that we have the equation 1.2. Okay, okay, so we have the our first in-class exercise for this subject. This is just a warm-up exercise, very, very simple. You may just use within, you can get the answer within 3 or 5 minutes, okay? So try to read the problem and then to do a calculation, okay? And at the same time, we may have to break. Yeah, so after you calculate or solve the problem, you may take a break, and then I'll see you at 10:30. Okay.